What is a
Half-life.
The half-life of carbon-14 is 5,730 years. What exactly is a half-life? It's the amount of time it takes for half of a radioactive sample to decay.
Our sample is 10 micrograms of carbon-14. But what is carbon-14?
Well, carbon-14 is a radioactive isotope of carbon that has 8 neutrons as opposed to the most abundant form of carbon, carbon-12, which has 6 neutrons. Over a period of 5,730 years, carbon-14 decays into 2 elements, half of which are the same, carbon-14, and half of which are nitrogen-14, the most stable form of nitrogen.
The sample we are working with is 50,000 years old.
Rounding is an important part of half-life calculations because decay is not constant. If you have, for example, 50 grams of a sample, on the first day, 24 grams of that sample could decay, and on the last day, the final 1 gram could decay, fulfilling the half-life. Once you reach the full length of the half-life, you will know exactly how many grams remain, but until then, you can never know. Therefore, we round to the nearest half-life in half-life calculations to get the best estimate.
First, create a table to organize your data.
Fill in what you know. In this case, the only column we're missing is the mass.
To calculate the mass, you start with what you're given, which in this case is 10 micrograms, and double it until you reach 0 half-lives.
We calculated the initial mass to be 5,120 micrograms. What is another example? Well, in this last problem, we were looking for the original amount of carbon-14. But in other problems you might be given, you could be asked to look for the final amount, or the number of half-lives passed, or just the years that have passed. To solve these, you basically use the same tactics that we just used in our problem. Basically, you would set up a chart like we did, but you go about it a different way. So for example, since we were looking for the original amount, we had to go backwards, meaning we went up the chart. But if you're looking for the final amount, you do the opposite and go down, or forward, basically. So as long as you have this chart to organize your data, you should be good to go.
Paleontologists often use half-life calculations, and more generally radioactive dating, to get a ballpark estimate of how old a sample that they obtain from an archaeological dig is. Now, for example, if you dig up some bones and they have 12 micrograms of carbon-14 in them, you can get a ballpark estimate of how old the sample is. Since you probably already have an estimate of its age, you can use carbon-14 to confirm it. And also, since there is a baseline level of carbon-14 in organisms that are living, you can use that value to calculate approximately how old some sample is, which gives you a much more mathematically precise idea of when an organism was from.
Thanks for watching!
We hope this helped.